We talked a bit about data frames and how to store them in Parquet files. This time we're going to talk in more depth about operations on data frames. So this is a large subject, and I'm going to talk only about a small part of it. You can read more in these pointers, and as we go along, as we do machine learning, we will describe maybe more operations as we need them. So remember the data frame we had in the previous video with the meteorological data. Its schema was the following. It had elevation, longitude, latitude, all doubles, measurement, that is a string, station, that is a string, undefs, which is a long integer, and vector, which is a binary vector. So it's really just, from the point of view of Spark, it's just a long binary thing, and it is packaged in a particular way that we will show later in this video. Okay, so these are the fields that we have, and now let's see some of the operations we can do on it. Here is the first line of it that we already saw, and the simplest operation that we might want to do when we first get a data frame is to use the command describe, takes no parameters, and it generates some basic statistics of this data frame. So for each column, it outputs the count, the mean, the standard deviation, the min, and the max. Okay, so let's see what we have from here. If we look at just the table that has station, elevation, and measurement, we see that there are 12,373 measurements of any one of them. When you have a string, to take a mean, standard deviation doesn't mean anything. The min and the max is just the first in order and the last in order. Elevation and measurement elevation has the following. It has the mean elevation, 205, the standard deviation of the elevation, and then the lowest, smallest elevation ever in this table, which is minus 999.9, which is probably wrong, and the highest elevation, which is 305.1. Okay, so this gives you just a glimpse into what's in your database. Remember, there's 12,000 elements, so you need a way to somehow just get a glimpse. Okay, so to get a little bit more information, we can use the command group by, which groups according to the value of the column, and then we can use the command aggregate to compute a summary for each one of the groups. Okay, so what do we have here? We're grouping by measurement, so the type of measurement. Then the aggregation that we have is for year, we have min, and for station, we have count. Okay, so basically, these are the 6 types of measurements that are in this data frame. You see how many measurements of each type. So you see that there is more of snow and less of T observed. And then you can see the min shows you what is the minimum of the years. So the first year that this measurement was obtained for T obs is 1901. And for precipitation, it's 1893. So even earlier, and T min is earlier. And then 1902 is for snow depth. Okay, so that is another way to get some statistics about your table. Using SQL queries on data frames. So SQL is simple query language that was invented for databases, and it has very nice properties that are used in data frames. So the two ways to to manipulate data frame, one is using methods as of the type we saw, select and group by, and so on. And the advantage is that you specify exactly in what order you want to perform the operation. The disadvantage is you need to describe both what you want to compute and how you want to compute it. So it basically forces you to think hard about what would be the most efficient way to compute the thing you want to compute. On the other hand, declarative manipulation using SQL, you only need to describe what it is that you want to compute. Okay, I want to compute the mean of the min values of all of these things, and so on. And the advantage then is that the compiler can basically optimize things much better than it can if you are restricting it in terms of how, in what order to do things. The disadvantage is that sometimes you don't have the low-level primitives to do the operations that you want. I think covariance has been added since I made these slides. Okay, so let's see this by example. So here is counting the number of occurrences of each measurement imperatively. So you basically do df group by, and then you do count, and then you do collect. And you get this, this list L, and you organize it a little bit in Python, and then here is the result. Okay? So this is the imperative way, the programming kind of way that you can do this operation. Here's the way that you can do it declaratively, without saying how to perform it, just what you want. So the first thing that you want to do is a little technical thing. You have to register your data frame to give it in the SQL and SQL context, and then you give it a name. This name lets you refer to it inside an SQL query. So here is the way we do it. This is the query. Okay, so it says select measurement, and then count measurement as count, and min year as min year. Okay, so this is the things that you want to get out, and then you want it to take it from weather that has been registered. DF has been registered as weather. You want to group those by measurement, and you want to order them by count. Okay, so this is what you want. You don't say how to do it, in what order to do it. This is just what you want the end result to be. And when you do now SQL context SQL query, it just executes this query on inside this SQL context. Okay, so what you get at the end is exactly the same thing. The advantage is that you were not trying to be specific about in what order to do things and how to do things. You just wrote them in the way that is most explanatory so people can immediately understand what it is you're trying to do. And sophisticated SQL queries can span many lines. They can be, in a sense, like little programs. The difference is that they don't have an execution order. They just have a requirement of what has to be computed. Suppose we want to perform a map command on a data frame. If we want to do that, then we first have to map the data frame back into an RDD and then operate on it as an RDD, because the data frame doesn't reveal to us this ability to do a map operation. And that is not the recommended way. It's much better if you keep things in the form of a data frame and then you use built-in Spark SQL functions. And you can also register new ones. That's an advanced topic that I won't cover. So first, the bad way to do it is here we take the data frame, we map it into an RDD, and then we perform the map operation. And finally, we take 5 of the top elements. Let's talk about aggregations. Aggregations are operations on data frames that you can combine with Spark SQL functions to compute various statistics of the data frame efficiently. And it's going to be efficient because you're combining the optimization in Spark with database optimizations. Okay, so the database operations are going to be performed hand in hand with the calculations. So here's a partial list of built-in functions. And here are the particular operation we're going to look at is approximate count distinct, which uses sampling over the different partitions in Spark in the data frame to calculate how many different elements you have. And if you click on this one, the gory details, you would see like a longer list of the functions that have been implemented already. So what we're doing here is a simple operation. We're aggregating, and we're using on the column station, we're using the function approx count distinct. So what that does is it counts how many different stations are mentioned in our database. Now, it's not going to be necessarily the exact same number each time. It might be 214, 215. So because it is calculating it just on a sample, it might be a little bit off, but it's not going to be much off. Another approximation you can use is to calculate quantiles. Okay, so suppose you want to take all of the records that you have, each one of them has a year, and you want to partition the years into 10 ranges. So from, let's say, 1900 to 1923, from 1923 to 1934, and so on. But you also want it so that in each one of these ranges, there will be approximately the same number of records. Okay, so this method, approximate quantile, can do this for us. And here is a way to do it. We're calculating the quantiles 2 times, and we're getting slightly different answers because we're asking for different levels of accuracy. Okay, so 0.01 is more accurate than 0.1, and we see that the years that you get are different, but they're not much different. Okay, so that shows you the power and the limitations of using approximations in your statistics. So to compare with this, we might want to calculate the exact number of rows for each year. So this is the way to do it in SQL. Select year, count year, as count, from whether, group by year, and order by year. Okay, so what we get is this counts that is a data frame and has these 2 fields. I'm not plotting out what these are, but once we have this, we can collect it into a pandas data frame. So we can translate counts that is a Spark SQL data frame into a pandas data frame, and then pandas has nice operations for plotting. So we say, I just want to plot the year versus the count. And what you see is that the number of measurements increases more or less monotonically from the early 1900s or the late 1800s to today. Okay, so this is basically a graph of the number of measurement years that we have for each measurement records that we have for each year. One of the nice things about using data frames and Parquet together is that even though Parquet is a file, it lies on disk, and we will see it can also be lying inside HDFS. We can actually make queries directly onto the file, and that can mean a big saving in time because we are basically going to read only those records that need to be in the response to the query. So let's see that, an example. So here is query. It says select station, measurement, and year from, and this is the special syntax here, parquet dot, and then you have the name of the file. And then where measurement is equal to snow. Okay, so now we have this query. This is the query after everything has been plugged in. And when we just do df2 equal SQL of query, then it basically performs this query directly on the file, not reading the whole file in, but using the Parquet column-wise structure to read just the parts that it needs. Okay, and then we're printing the count and the columns. So these are, the count is 2178 and the columns are these, and then we're just showing the top 5. Here they are. So these records actually were read from the file, but the other columns, for instance, were not read from the file because I'm saying here select station measurement year, right? So the columns that are the other columns, we don't need to read them. We don't need to get them from disk. And that's a very nice feature. Okay, so to summarize, data frames can be manipulated declaratively, which allows for more optimization. Data frames can be stored and retrieved from Parquet files, and it is possible to refer directly to the Parquet files in the SQL query. See you next time.